Okay, this is pre-calc number 114, lesson 114, number 6. So it says, sketch the graphs of the following polynomial functions. Use dots to indicate the locations where the graphs intersect the x-axis. So we know that they are going to intersect the x-axis whenever y equals 0. So we can use zero product property. It's already factored for us. We're going to set this thing equal to 0, and we're going to find out, what the zeros are on the graph. So we started out with this. I can see this with my eyeballs. I can see it's going to be shaped like a cubic. I wrote cubic like that because I know that if I really were to distribute this out, I'd have x cubed plus 3x squared. So I know it's probably going to have a cubic-y looking shape, and I know cubics usually kind of go like that. Okay, but I want to, the book says I'm supposed to use dots to indicate where the graph intersects the x-axis, so that makes me have to solve for x. So use the zero product property, so that means x squared equals 0, or x minus 3 equals, x plus 3 equals 0. But then if I subtract 3 on both sides, that's where that came from. So I have a multiplicity of 2 here, because x squared, x times x equals 0. So it's kind of like there's two factors. So that's, I don't know if you remember, some of you were in my algebra 2 class, and we used to have to say what's the multiplicity of it. This has a multiplicity of 2. If I had x plus 3 times x plus 3 like that, then negative 3 would have a multiplicity of 2. But I don't have that in this case. I just have one factor of it. So this means we're going to cross the x-axis at negative 3. And then this tells me whenever you have a even multiplicity, you're going to, like, I call it bumping the axis. You're just going to kind of hit it and then come back, go back in the same direction you came from. So in either case, you're going to put little dots. It told us to put dots wherever. It said right here on 6, use dots to indicate the locations where the graph intersects. Okay, so I know it's going to intersect. It's not really going to intersect, it's just going to bump it at 0, and it's going to intersect at negative 3. Why is it going to bump it at 0? Because there's two factors. It's like this is x times x, so there's two factors. It has a multiplicity of 2. That's an even multiplicity. And then I just fake it. Now, I could do a better job at that. I just know that cubics, they usually come up, like they point to the right, they point up, and to the left, they point down. Unless I put a minus sign in front of it, then it would go the other way. But it doesn't have a minus sign. So I just know that. So you kind of need to know, remember I showed you all these things? You kind of need to know the shapes, have an idea about the shapes. I just know that this is going to have this shape. So I kind of faked it. If I really wanted to make it nicer, I would probably try plugging in one of these points right here. I'd plug it in over here to see maybe this goes a little bit higher. I don't really know. I'm not being picky. Well, maybe I'll be a little pickier. I got some time on my video. Let's be a little bit pickier. Let's pick, how about negative 1? That's a nice number. And just see, maybe I didn't make it go high enough. I just guessed. So we'll use a number. Negative 1. If I put negative 1 in, I guess I'll just put in right here. Negative 1 squared is 1. And then that would become 2 if I put a negative 1 in there. So 1 times 2, that's 2. So negative 1 comma 2. So, I mean, it's still not perfect because we don't really know that it turns right there. We don't know that it turns right there, but we know, and you can plug that one in too and see it's got to turn somewhere, or else it wouldn't be able to get back to here. So, but again, I'm not being really picky on that. I hope that you know that it's just a sketch and not a perfect replica. But this could still be helpful in some situations. So that's your answer right there. Just sketch the graph. And it wants these 2 points. So Okay, so now we're on 114, number 8. 114, number 8. So it says, oh, and there's all these little pictures, and I think they're big enough for you to see them. All these little pictures. It says, which of the following graphs most resembles f of x equals x times negative 1, or x times x minus 1 times x plus 2. So I'm going to find the zeros of the graph. Or in other words, I'm going to find where it crosses the x-axis. This first factor gives me x equals 0. The second factor gives me x equals 1. And the third factor gives me x equals negative 2. So I can rule out some of these graphs. Any graph that doesn't have little dots at 0, 1, and negative 2, I'm going to get rid of. So let's see. 0, 1. I like this one. That one's okay. This one's no good because I need 0, 1, and negative 2, so that one's no good. 0, 1, there's no extra stuff on here. I don't have a factor of x minus 2, so it can't be that. Actually, I can see it's a cubic. I mean, I already know it's letter A because this, the highest degree, if I FOILed these all out, I'd have x cubed. Like all the x's, the highest degree would be x cubed. We can keep going though and rule out some of these. This one I'm going to rule it out because I don't have anything at 0, and I know it's supposed to touch the axis at 0, so I'm ruling that one out. And then this one, oh, so this one has what I want, but it has an extra part, doesn't it? This one has an extra piece at negative 1. So it has the stuff I want, but it has an extra one, so it's not that one. So basically it's A. Okay, and you can tell stuff by the end behavior too. Like if I wanted to go through and say what these are, there's a cubic, that's a negative quartic, or in other words, it's something raised to the 4th power, like negative. You could say it's x equals negative, or it's y equals negative x to the 4th-ish. That's going to be upside down parabola, so that'll be something like negative x squared. That would be a negative quartic, so negative x to the 4th. Okay, why is it negative? Because both ends are pointing down. Same with this one, same with this one. These are the two positive cubics. And I guess that's all for now.